Welcome to SolidCAM Professor on our series of Jumpstart, the easy way to get up to speed in SolidCAM. I'm Sydney, your SolidCAM Professor, and in this session we'll be doing part 4 of our first lesson. Now that our face mill operation is complete, we can add a profile operation to machine the outside dimensions of our cover. Once again, we right-click on Operations, highlight Add Operations, and select Profile. When our Edit Operation dialog opens up, you will notice that the workflow is very similar to what we saw when setting up our face mill operations. We will start by defining our geometry. We're going to select a chain that runs around the perimeter of our part. There are multiple options available to us when defining our geometry. We will discuss two of these in this example. The first option is to start by selecting an edge, then one at a time, click and highlight all subsequent edges until we have worked our way around to the beginning. Take notice, when selecting an edge, this red arrow appears. This arrow represents machining direction, and you should be aware of whether you want to perform a conventional or climb cut. Also, the point where your mouse arrow is sitting when I select the first edge will be my initial XY position in my G-code when we are ready to machine this profile, giving us control over where we would like our profile machining to begin. Now we can take a look at our second option of chain selection, Auto Constant Z. In order to show it to you, we will disregard our initial chain by clicking on the red X. What we will do is start by picking a single edge for our chain and the Select Auto Constant Z option. As you can see, rather than click on individual edges to construct our chain, it automatically grabs every edge located on the same Z level and connects them to our initial edge selection. With one easy step, we were able to create this entire chain. Click Yes to accept, then select the green check and our geometry has been defined. Our next step is to create our tool. Once in our tool dialog, we click Select. The only tool we have defined is our face mill, and that would not be acceptable for our profile operation, so we can select Add and choose an end mill. We will use the default tool values for this exercise. We can also add a tool holder to our end mill by clicking on the Holder tab and selecting Global Holders table. As you can see, we have a series of different holders available, and we will grab the first one on the list. You will also note, if we drag our mouse onto our part display, you can view the tool and tool holder in real time. Any changes we make to the tool are updated visually and can be viewed on the fly. With the tool now defined, we can move to the levels area. We have the ability to pick our levels right off of the model. Simply click on the upper level button, then come over to the model and pick the feature that represents our upper level. Our profile depth is handled in the same manner. Simply pick the feature off the model that represents the profile depth. Our technology field is up next. We can start with tool side. This controls what side of our selected geometry we will be working on, and our choices are left, center, and right. We will be using left for this lesson. The compensation box handles whether or not we want to use cutter compensation when we output our G-code. If we put a check in our rough option, we can do both a rough and finish cut pass. We can leave material on our wall and our floor, then we have the tool come back and machine off the excess material. In this case, we will use 0.3 millimeters on our wall, and we will set our rough step down at 3 millimeters. We are going to leave the number of passes for our finished cut at 1, meaning our tool will come down to full profile depth and remove 0.3 millimeters on the wall in a single pass. The last area we have to set is link. This controls how we would like our cutting tool to enter and exit our part. When we open the drop-down in Lead In, we have 5 options. Every time we select an option, the diagram over here shows us visually how the tool will lead in to the cut. For this exercise, we are going to use an arc lead-in, and we will set the value at 4 millimeters. That means my tool will do a 4 millimeter arc into my profile cut. Now in lead out, we have the same options available to us. To simplify things, however, we have a checkbox called same as lead in. If we check this off, our lead out will use our lead in type and will set the value to match 4 millimeters in this instance. At this point, we can now save and calculate our toolpath. This concludes part 4 in lesson 1 on our series of Jumpstart. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.